In this video, we're going to simplify radicals. So, for simplifying radicals, you're going to need to know perfect square integers. So, starting with 2 squared being 4, 3 squared being 9, continuing on 16, 25, 36, 49, 64. These are all perfect square integers. So we need to know those to help us with these problems. Obviously, if you come across a square root of one of these perfect squares, those are pretty straightforward. Square root of 9 is 3. Square root of 25 is 5. So those are ideal when we have perfect squares. But what happens when you have a problem like square root of 90? 90 isn't a perfect square, so how do we simplify that? Well, what we're going to make is what basically is a factor tree. We've done factor trees early in our math careers, so let's make a factor tree for the square root of 90. Two factors of square root of 90 are square root of 45 and square root of 2. So this is true. These are both factors of square root of 90, but it's actually a poor choice for what we're trying to accomplish. Neither 45 or 2 are perfect squares, so that would be a bad choice for this task. When making your factor trees, try to think of which factors are perfect squares. If I had chosen to do square root of 9 and square root of 10, that would have been a better choice, because square root of 9 is 3. So we've simplified our radical. The square root of 10 has no factors that are perfect squares. No factors of 10 are perfect squares. Factors are 1 and 10, 2 and 5. None of them are perfect squares. So when you hit that wall, we are done. So we have simplified square root of 90 completely, and that result is 3 square root of 10. This is the simplified form, and it is simplified completely. Here's another example. The square root of 128. So again, we're going to make a factor tree, and you want to think of factors that are perfect squares. So one that's used a lot is square root of 4. That's a nice number that goes into 128. So square root of 4 times square root of 32. Square root of 4 can be reduced to 2. So now we're left with square root of 32. Well, we're not done. There definitely are factors of 32 that are perfect squares. So we can definitely keep going. Let's continue our factor tree. 2 factors of 32 are square root of 4 and square root of 8. We chose those because square root of 4 is a perfect square. That can reduce to 2. When you look at square root of 8, we can keep going. There are factors of 8 that are perfect squares, being square root of 4 and square root of 2. Square root of 4, again, is 2. Our factor tree is getting long. When you look at square root of 2, there are no factors of 2 that are perfect squares. So we are done with our factor tree. Now you may be asking yourself, well, isn't 1 a factor of 2? And isn't 1 a perfect square? Yes, that's true. But in this process, we're going to ignore 1. Because if you think about it, if you factor out 1 from a number like 5, when you factor out 1, the result is still 5. So you haven't changed or reduced the number in any way. So for this process, we're going to ignore 1. If you multiply up your branches of your tree, you have 2 times 2 times 2 times root 2. Final result is 8 root 2. And that is the simplified completely result. Well, let's do that problem again. The tree got kind of long. I want to try and do the same process, but I want to try to do it in 1 step. I want as little work as possible. I want as little branches in my tree as possible. So to do it in 1 step, try to think of the largest perfect square that is a factor of 128. When we did the problem just now, the first number we chose was 4. Let's try to do it again, but think of the largest perfect square that is a factor of 128. Well, if you think about it, that number is 64. 64 is the largest perfect square that is a factor of 128. So if that is my first branches on my tree, it would look like this. The square root of 64 is 8. I'm done when I look at square root of 2. So my final simplified answer is 8 root 2. We were able to do it in 1 step. Okay. Another example that we're going to try to do in 1 step. Let's simplify the square root of 300, and let's do it in 1 step. Simplify square root of 300 in 1 step. Again, to do this, we need to think of the largest perfect square factor of 300. That would be 100. So my factor tree looks like this. The square root of 100 is 10. Square root of 3 is a dead end in terms of simplifying. So my final answer would be 10 root 3. So let's take a look at where this could come into play. How could we use this practice to help us in our math problems, more complex math problems? Well, here is a fraction. We have square root of 54 over 3, and I want to reduce this fraction. Well, to do this, I first want to simplify the radical. Square root of 54, we now know to be 3 root 6. So that makes it more apparent as to what can cancel with denominators. In this case, 3 can cancel with the 3 in the denominator, leaving us with just root 6, a much more simplified form than square root of 54 all over 3. Here's another one, square root of 8 minus square root of 20 all over 2. Let's simplify square root of 8 to 2 root 2. Simplify square root of 20 to 2 root 5. That's all over 2. Now it's more apparent as to what can cancel with my denominator. All the 2's can cancel. So my simplified answer is square root of 2 minus square root of 5.